We get a lot of questions about how RAS 2025 is going to interact with the previous versions of RAS, and in particular, how RAS 2025 is going to handle 1D. And we'll have a lot more to say about 1D in months to come. But I wanted to show you a pretty quick workflow where you could use 1D cross-sections to build a simplified mesh and get very similar answers in RAS 2025 with some pretty powerful tools that we already have in there. So I have this 1D model in RAS 6.7, and I would like to do a similar simulation in RAS 2025. So how would I do that? Well, the first thing I'm going to do is I'm going to go to RAS Mapper. And here I've got my cross sections and my center line. I actually don't really need my center line. If I wanted to do it as kind of a true one-dimensional model, really all I need are my cross sections and some sort of bounding polygon. Well, how do I get that bounding polygon? Well, I just come in here to my cross sections, I start editing, and if I don't already have an edge line, I can come in here and say create edge line at cross section limit. What that does is it will create some polylines along the edge of my model, which will give me essentially the bounding arcs for my RAS 2025 model. And so if I wanted kind of a true like 1D-ish RAS 2025 model, I could just export this. But in general, when I'm looking for simplified modeling, the fact that we used to do 1D modeling is really just an accident of the technology. I think the simplest modeling that I would like to do is a 3-cell model where you have the channel which is distinct from the overbanks. And so the other thing you can do is you can come in here and right click on your bank lines, and you can say, if you don't have digitized bank stations, you can come in here and say create bank lines from your bank stations. And what RAS will do is it'll use a pretty sophisticated interpolation tool to draw those bank lines. Okay, so now what I can do is I can export the cross sections, the edge, and the bank lines to get a 3-cell model in RAS 2025. So I'm going to come in here, I'm going to skip rivers. You could do that if you wanted to split this into 2 cells, but I don't. I'm going to come to bank lines, I'm going to export, and I'm going to export to a shapefile. And I'll just put it in this folder called demo shapes, and I'll call this banks. And then I'll come here to my cross sections, and I'll export those as shapefiles as well. And then I'll go to my edge lines, and I will export those as shapefiles as well. All right, so now I have all the lines I need for a RAS 2025 topology. So if we go into RAS 2025, what you'll see is I've already imported the terrain, and so I'm going to come in here and I'm going to create a new geometry, which I'm just going to call demo. All right, and then I will turn it on and come to my conceptual mesh, and instead of tracing this out, I'm going to right click on my conceptual mesh and I'm going to import polylines and polygons. And I'll come in here to my demo shapes, and I'll just get my bank shapefile, my edge shapefile, and my cross section shapefile, and I'll open them. And it asks me this question. It says, do you want to just import them without a merge, or do you want to import and merge? And what Zach does here is he has some pretty sophisticated logic to look at where these intersect and try to turn it into an actual mesh. So I'm going to go ahead and import and merge. And what you'll see is that the polylines come in and they find the right topology where they intersect, and they make specific arcs. Okay, so now I actually have a series of arcs. All of these cells, because of the nature of what 1D is, all of these cells have 4 faces, which means they can be quads. And so what I'm going to do here now is I'm going to press Shift and I'm going to select all of my arcs, and I'm going to go to count, and I'm going to say I actually only want 1 cell on each face. What's that going to do? Well, in general, that's just going to make kind of each of these arcs a cell, which is essentially 1D, or in this case quasi 1D. And so we're going to go ahead and put that in there, and then we're going to go to the regions, and we're going to select all the regions. I'm going to press Shift, and we're going to turn all of those into quads. And so now if I come over and I regenerate my mesh, well, it looks like hardly anything happened, because each of these now is a mesh cell. You can see that RAS decided to give us one additional face here. I could change my tolerances to get rid of it, but hey, if RAS thinks I need it there, maybe I'll keep it. And so now I have essentially a 3-cell wide mesh using the one-dimensional cross sections. So now if I go and create a plan, and we'll call this demo, and I get my demo geometry, and I've already set up my boundary conditions, so I'll go get those boundary conditions, and let's run it for one day because this is a steady flow. So we'll just go ahead and put 1 day in there and create. Now if we go to that plan and compute, we can go and look at our demo, we can look at our depth, and we've essentially used our one-dimensional model to make a simple 3-cell, 2-dimensional model to get a much stronger result. Now, if you're thinking, hold on, you said you were going to use the cross-sections, and you just used the cross-sections to make the boundaries of cells. What we've actually got here is just a 2-dimensional model that has very large cells and isn't actually using the cross-section data at all. I understand why you would think about it that way, but you have to account for the subgrid technology. When you're using RAS, you always have to think about the subgrid technology and what that's doing for you. And what that's doing for you here is that each one of these cross sections we brought in is actually behaving as a cross section because we sample the terrain along each of these arcs and use that terrain profile in order to modulate how flow moves between the cells. And so if you were to get rid of these kind of bank lines, you would have essentially a one-dimensional model that uses our same two-dimensional equations to move water from this cross-section to this cross-section. Adding the banks makes it this 3-cell model, which gives it a little bit more fidelity, but we are actually using these cross-sections in the model. And so that's just a brief demo of how you could use a one-dimensional topology to make a RAS 2025 model. That gives you just a little bit more functionality, but runs very quickly. It would run very quickly on a large scale to do this kind of modeling.